Yeah, we will.
So a couple of PowerPoint slides and then I can go to the there's a way to do it. Yeah, it should be.
So over the semester, Alice and I worked on separate projects, but about halfway through, Mark gave us a suggestion that they could work together. So for our demo, we're having my planner that takes a start position and an end position and gives a bunch of points, and Alice is able to get from point to point. So for the RT planner, it's given a start position and end position and a map of the environment. As you can see on the field, there's some obstacles set up. So we've given that.
Before you continue, can you give the original goal of your project?
The original goal of the project is to create a planning algorithm for the robots. We can compare them with the algorithm that Alex is writing. Over the summer, I'm going to work on more algorithms and stuff, but right now I'm working on the chance constrained RRT, which is an algorithm written by the MIT Looters paper. So I'm working on implementing that so we can compare Alex's algorithm. Right now, what the algorithm does is it generates a piecewise linear path from the starting position to the end position. And so it's going to give a bunch of X and Y points that Alice can put into here.
So the aim of my project this semester is giving a piecewise linear path, a set of points. I want the segway to go from a point to the second point. So what I did is my model predictive control needs a reference path so the segway can follow it, but we need a dynamically feasible path. So what I started doing is that I just connected the points by straight lines, and then I ran the controller in simulation and saved the data as the reference path, and then gave them to the segway. And in order not to have just abrupt like turns, I just set a margin for error at the angle. So if it is above a threshold, the segway will just turn until it reaches the threshold, and then the controller will go. So our demo is going to be like we're going to just put a person. Yeah.
Why do you want this? What did you turn on?
The error between where the segway is versus where it's supposed to be. So the reference path is where it is supposed to be, and the Vicon system here will give me where it is. And the model predictive control will get the error between both, and we try to, and we have also reference input, so we try to modify the reference input, so the segway will track the error.
So when you said simulation, optimization system to make sure you're projecting for right. You said something similar.
Yeah, so I said the reference path should be dynamically feasible, but if I just put straight points between the points, and there's an error in it, the segway will just go down the straight line. So it will tend to curve and then go back toward the point. So what I did is I ran the controller internally in simulation without giving commands to the segway, and I estimated the segway's cost by just dictating the geometry and using my models. And then I kind of...
You might want to remind people about the model from last semester.
Okay, so last semester the segway has a black box, and I identified the dynamics of the forward velocity. So now I kind of have a model for the transient and steady state response of the segway. And at the beginning of the semester, I did the same thing for the angular velocity, and I have a good estimation. But for the angular velocity, the segway has an overshoot, but my model does not recover the overshoot. But this is taken care of inside the simulation, because when I design my model predictive control, I have to optimize over two parameters: the frequency response and the damping ratio. And then when I have just straight lines, I just take my references, which are straight lines, and I run them internally using my model, and I kind of estimate what the segway behavior would be, and I will take these output as my reference path. And then the frequency response I use in simulation is higher than the frequency response I use on the segway, so that because of the overshoot, that way it can be easier.
So what is the model control? So you're running the full path, and then you're changing your output space on the full path?
Yes.
So it's not quite a traditional path, which you're running on line and correct it as you go.
Oh,
Or
yes,
is
that's right. But,
How often are you doing that?
oh,
how often?
every time.
And every time that you're doing is simulate, and then,
series at the end?
Oh, no, at the beginning, so I need a reference path. And then instead of taking just straight lines, which is a very weak reference path, I'm running the computer internally without giving comments to segue, just to predict what the segue would, where would the segue would be in reality. So if the segue is facing that direction and I want it to go in this direction, and I run my controller, I would have an output that would curve and go back, and I would take this output as my reference path.
but then when you redo that simulation and optimization, do you redo that at every time step, or do you just do it for a full path and then run the path?
I do it for a full path, and then I give the segue this path, and I run the controller.
So, yeah, you know, you do this part, so you run, I understand what you're saying, I can do straight lines, okay? You have a model that says, what do we do if we have straight lines? You run that and you get the reference right.
With the controller.
Yeah.
Okay.
What do we do?
Okay, so I have a straight line, and I have to run the controller if I have an angular error, because if I do not, the segue would die.
Yeah, so you're creating a path
Yeah.
that's feasible,
Yeah.
and the control inputs that will give you.
Yes, and then I
And then you
take,
run that?
no, I take these as my references, and I feed them to the segue, and I keep track of where the segue is, because if there's an error.
So at any time step, you're projecting from where you are right now.
Yes.
I'm asking.
Oh,
So at any time step, you're projecting the rest of the path and correcting based on that?
no. Yes, yeah. So at every time step, I'm like, okay, my reference path says that I should be here, but now I'm there. So the controller will run and will notify the next input. And then at the next time step, it will
Okay,
also.
and that is not, okay, so now that.
The reference, when you finish the smooth reference path, which you think is feasible, do you ever change that smooth reference path?
No, it is a reference path, but then if there is error, the controller will notify the input.
Not only if there's an error, any time you
Yeah,
check, and
yeah,
it's
checks.
good and good and
Yes.
good, right?
Yeah.
I think where the disconnect here is happening, I think what Alice was using, developed a model predictive controller which boiled down to a simple.
Yeah, but it's doing it every time step and projecting forward.
No.
Oh,
It boils down into a simple feedback.
oh, top notch.
It is, but it happens to be that their formulation boiled down into.
It's the model predictor for one time step.
Yeah.
Yeah,
So
right.
Yeah.
But it has, like I say, it basically has steady state gains. So they use a model predictor just by their work.
Getting rid of the predictive.
No, they did the predictive aspect of it, but the resultant controller ended up having steady state.
When it comes to confusion lies in the traditional model predictive control is that if you simulate the path all the way from the beginning to the end, that's never ever going to be implemented. Because what happens is you start down that path and then you have to re-optimize the whole path again. So what happens is you optimize over a small horizon, implement a little bit, and then you re-optimize the whole path again, like that. And that's what model predictive control. You're using a model of the segue, and so some idea of where you want to go, and you're optimizing over that small little horizon. And you repeat that. So I think that's, I think it's a little bit different than what you're doing, but I think the framework, my understanding is the framework that you have to do it, it just turns out the implementation you have right now is just on a single smooth path.
Yeah.
So you do it basically once, one time. The initial step is the model predictor, and then you just do that.
Well, I can reference you the paper.
I think the implementation is not the same, the framework is the
So,
Just wanted to understand.
okay. So for our demo, we're gonna have a helmet on the map, and then the robot will track the helmet. But because I got ran over by the robot, it's not very safe. The volunteer was
Okay. Why did you pick my own friend?
I was trying to scare this. It was back.
So, no, what did you do?
What?
I'm curious about what you did.
Oh, okay. So I had, yeah. So I was, I wanted the robot to go into a square, and then wasn't sure that all my angles were back eventually. And then it turned the first corner and the second one. And at the third corner, it turned. I was behind the robot just to stop it in case something happened. It turned out to be
Because it was looking at the reference frame and then.
yeah, it was an angle issue and
What do you mean with that?
so about the angle that my slide eye.
It was like a
Oh,
native
yeah.
hair somewhere.
Something happened.
Fucker, fucker.
So for this, it's gonna go from the starting position of where the segue currently is to the helmet, but it's going to exactly where the helmet is starting, so we're gonna provide a volunteer.
Yeah.
Can
First
we
safety
can we
issue.
just put the helmet on the floor, please?
But
Or on
And then move it once more?
We can, because the thing is, if you change your position on the map, it will just
It
take to
doesn't-
the initial position.
it just
So you can just stand and
You
then
can step
move
away.
backward.
yeah, you can step away.
And
So,
you're moving,
so
so
what's
what's an
going
RT?
to?
You have a place you're trying to move to.
Yeah, but if, okay, so we're gonna start by just getting the position of the helmet and the position of the robot, and we generate the RT, and then we run the controller. But while the controller is running, if the position of the helmet changes, it will not bring that.
So what do you need to focus on?
It's kind of,
It's fun.
So, I agree, but to some extent, our main mission is to make sure everybody's alive.
Everyone's gonna be, it's not
Yeah,
gonna
we tried it on
okay,
Alex.
We did. We tried it on Alex. It's fine. It's not gonna go that fast. We set the velocity very, very fast.
Come
on, Mark.
I mean, if you have a person stand there with a helmet, just if a person was walking around, like,
You can put it on.
All right, I guess. All right, guys, I guess we'll do that.
Would